Hi, this is Maggie. In this video, we're going to talk in a little more depth about methods. So methods, for a quick overview, are the operations that we write that are associated with an object and generally allow us to access or transform the state of the object. The state of the object is its data, or fields. This class, ShoppingList, manages a list of shopping items and also a list of all items ever placed on the shopping list. When we create an object of class ShoppingList, its data is those two lists. We can categorize these methods into three categories. We have an initializer, which I sometimes refer to as a constructor, the method that puts the object into an initial, meaningful, stable state. That's the __init___ method. And then there are two other categories that we'll talk about, accessors and mutators. Accessors give the program using the object access to the state of the object, and mutators allow the program using the object to change the state of the object. Before I give it away, look at these methods: add item, remove item, get list, and get all items, and think about what category you would place each of these methods into. Pause the video if you want a moment. Okay, so two of these methods access the state of the object, and those are getList and getAllItems. This doesn't mean that the user of the object gets to have access to the fields or the data in the fields, and I'll add two methods in a moment that allow access to the state of the object without directly returning the values in a field. But hopefully it is clear that these methods reveal something about the state of the object without allowing it to be changed. So they're accessors. The other two, add item and remove item, are mutators because they change at least the items list, and add item sometimes changes both lists. So they alter the internal state of the object. You might have noticed the accessors don't take parameters, but they return a value, and mutators take parameters but don't return a value. That's a general pattern, but of course an accessor might take a parameter and a mutator might return a value. For example, a mutator might return a boolean result indicating whether the change was successful or not, and we could write an accessor that takes a number, for example, and returns that item on the shopping list. But I'm going to add two more accessors, and those are going to be getNumItems and __str__. Let's start with getNumItems. It's going to return the number of items on the shopping list. So def getNumItems, only self as a parameter, and it will return an int. And then inside, I'll write a docstring, and return len self.items. So there's an accessor that gives us information about the internal state of the object that isn't just returning a field. And that's an important thing to understand, although very difficult to understand at first. The accessors and mutators are operations we want to be able to perform on this object, but they're independent of the implementation. When the software is designed, we might say, we need a shopping list, and we need to be able to access the information about the list in these ways, and we need to be able to change the list in these ways. But that says nothing about how it is actually done. So we can change how this shopping list object is implemented, and it will have no deleterious effects on the parts of the program that use it, as long as we keep those methods, the public part of the object, the same. Not the implementation of them, the signatures, the way they're used. Now we'll write the string method. Like the init method, this is a method that has special meaning to Python. To illustrate the value of this method, I'm going to compile my ShoppingList class and create an object in the console. After I've made it, I'm going to print it. And what I see isn't very meaningful. It appears to be the address of the memory location on the heap where the object is stored. So I'll write the str method, def underscore underscore str underscore underscore self, and it returns a string. And what I do in the body of this method is I create a string that is what I want to be printed in the console when we pass the object as an argument to the print function. I'm going to be relatively lazy, but we could create a nice, neat output in theory. I'm just going to concatenate some things together. Items, colon, space, and I'll concatenate a string version of the items list to that. And then I'll concatenate a new line, all items, colon, space, and then the string version of all items. And I'll return that. Now I'll compile this again and again create a ShoppingList object and print it. And now you can see that it displays what I wrote in the str method. And this is an accessor because it accesses the state of the object, this time as a string. Now, one other topic I wanted to discuss in this video is default parameter values. And for this discussion, I'm going to bring up another example, the image class. This class has for data the pygame surface representing the image, the x coordinate of the image, the y coordinate, and whether or not the image is selected, a boolean. When the image object is initialized, we pass in the file name to load as a surface and the x, y coordinates. I'm going to give the x, y coordinates a default value each of 0, which I write simply as equals 0 after each parameter. Now, the user of this object has options. They can either pass in one parameter, the name of the file, and the default values of 0 will be used for the x and y coordinates. Or they can pass in 3 parameters, the name of the file, and the x and y coordinates, and the zeros will be ignored. Now, they could also pass in 2 parameters, the name of the file and the x coordinate, but in this situation that seems a little odd. Practice with these concepts by classifying methods of different objects as initializer, accessor, or mutator, and consider adding a str method to some objects you have written. What would you put in the str method of the image class? What are the accessors and the mutators in this class? You might also think about how implementation is separate from the public interface and why. As always, have fun.